Hi, welcome to the fourth video of the quantum physics series. In our last video, we learned about the fermions and bosons that the standard model comprises. Today, what is the difference between bosons and fermions? The Pauli exclusion principle. Do you remember when your teacher showed you the different atomic models? They were not tiny balls or plum pudding after all, right? The electrons orbit around the nucleus. The thing is that in the 20th century, we realized that they did not orbit like planets around the sun. The electron's position is not determined, and instead we talk of the regions of space where it is highly probable to measure the electron. To define these regions of space, the orbitals, we use the so-called quantum numbers. Imagine them as the address for the electron's house. The principal quantum number, n, is like the neighborhood of the electron, telling us its energy level. The higher n is, the more energetic that electron will be. The periods of the periodic table tell us the value of n for the outermost electron in an atom. The second quantum number, or azimuthal, L, is like the street within that neighborhood, giving us the orbital shape. This can be spherical, elliptical, or otherwise, but that's another story. Lastly, the magnetic quantum number, M, points to the specific house on that street, indicating the orbital orientation. These two orbitals, for example, have different values of m. Now let's talk about the Pauli exclusion principle. Picture this. Our quantum neighbors, the electrons, follow strict rules. No two of them can have the same address. In quantum terms, this means no two electrons in an atom can share the same set of quantum numbers. Why? Well, it's like having two guests with the same invitation to a party. They can't both occupy the same space at the same time, right? The Pauli exclusion principle ensures that the electrons in an atom keep their own quantum address to avoid chaos. But, as you know, electrons are fermions. The difference between fermions and bosons is that bosons can indeed share the same set of quantum numbers. For instance, these two people can see the dogs in front of them without a problem because photons are bosons, and thus they don't collide in the middle, because they can share the same set of quantum numbers. Hey there, thank you for staying until the end of the video. Follow for more and see you next time.